Assalamualaikum and good day to everyone. So in this video, we are going to discuss the aldehydes and ketones tutorial question. Okay, so similar to alcohol question just now, in the previous video, I have assigned a volunteer for to answer this aldehyde and ketones question. Okay, so I have assigned Christina Alia. Okay, and thank you, Christina Alia, for providing the answer for me to discuss in this video. Okay, all right, so let's just proceed. Okay, question. So we're going to start with question number 27. Okay, right, aldehydes and ketone. Draw the structure of the following compound. So given the IUPAC beam of the compound, so you have to draw the structure. Okay, right. Sorry, let me just open the file of my answer scheme first. Right, tutorial. Okay. Okay, so 2-chloro-3-methyl pentanal. Okay, all right. So let's check the structure for this molecule. Okay, so we have pentanal. That means we should have 5 carbons, and it is an aldehyde. That means the carbonyl should be placed on the terminal, at the terminal lah. So it should be the terminal carbon. Okay, so this would be number 1, number 2, number 3, number 4, number 5, and carbon number 3. 1, 2, 3. We have methyl group here, and then at carbon number 2 we have chloro. Okay, so this is correct. And then B 4-bromo-3-methyl butanal. So it is butanal. That means we have 4 carbons. 1, 2, 3, 4. And then carbon number 3, we have methyl group. Okay, starting from here. So this is methyl group at carbon number 3, and carbon number 4, we have bromo. Okay, so the priority will be on the functional group itself. Okay, so we are going to assign carbon number 1 to the carbonyl carbon. Okay, all right. So this is also correct. Right, then C3-methyl-2-pentanon. Okay, so we have 5 carbons there, and it is it is a ketone. Okay, that means the carbonyl group is located between the 2 carbon. Okay, so and the carbonyl is located at carbon number 2 in the parent in the chain. Okay, so 1, 2, 3, 4, 5. At carbon number 2 we have carbonyl group, and at carbon number 3 we have methyl group. So correct. Numbers, the last one. Okay, 4,4-dimethyl cycloheptanon. Heptanon. That means we have 7 carbon, and it should be cyclic. Cyclo, because the word the prefix used is cyclo. So 1, 2, 3, 4, 5, 6, 7. So there should be 7 carbon in the cyclic, and then it is a ketone. Okay, so you can assign apa nama to the carbonyl group to any of the carbon in the cyclic. Okay, so let's say kalau Christina, she assigned this carbon as carbon number 1. She assigned this carbon to this carbonyl group. That means this would be carbon number 1. Okay, and then starting from here, 1, 2, 3, 4. So we have 2 methyl group here. So that's why it is 4,4-dimethyl. Okay, also correct. Very good. Okay, 28. Let's just name the compound. Oh, bukan. Nama dia draw and name all the question dia draw and name all the possible isomers of carbonyl compound with molecular formula of C5H10O. Okay, so you have to draw all possible isomers of carbonyl compound. That means compound that has carbonyl group lah. Okay, carbonyl functional group in it. So it's either ketone or aldehyde, as long as it satisfies this chemical formula. Okay, all right, so let's just check. So we do have pentanal. We also have 3-methyl butanol. So as you can see, these two are aldehyde, and then other than that, we also have 2-methyl butanol. It is also aldehyde, and then 2,2-dimethyl propanol. Okay, so kita ada lagi satu sebenarnya for aldehyde. So we have 2,2-dimethyl propanol. This is double bond O. So this is also an aldehyde. Okay, so 1, 2, 3, 1, 2, 3, 4, 5. So it has 5 carbon, and then hydrogen. We have 1, 4, 7 plus 3, 10. Hydrogen we have 10, and then we have 1 oxygen. So it satisfies the chemical formula. So this is known as 2,2-dimethyl propanol. Okay. Right. Next we have for ketone we have 2-pentanone, and then we have 2-methyl 2-butanone. Is it? Yeah. 2-pentanol, 3-methyl 2-butanone, also correct. And then we also have 3-pentanone. Okay, so the drawing are all correct. Okay, so these are ketones. So we have 4 aldehydes and also 3 ketones that satisfy this chemical formula. Okay, right. B, question B. Based on, this is C. Where is B? Okay, maybe Christina missed out the B. Think so. Tinggal kot B. Based on the structure you have drawn in A, okay, choose the compounds that can be oxidized with hot CHM096 plus. Okay, so the question for B is you have to choose the compound that can be oxidized with hot CHM096. So CHM096 is an oxidizing agent. Okay, so between ketone and aldehyde, the one that can undergoes oxidation with oxidizing agent is aldehyde. Only aldehyde, all aldehyde. So basically you have to name all the aldehyde lah. So all these pentanol, 3-methyl butanol, 2-methyl butanol, and 2,2-dimethyl propanol. So these 4 will undergo oxidation, okay, with hot CHM096 H plus and H plus acidic lah. Okay, and then that is for B1. For B2, the question is the choose the compound that give positive result with Fehling solution and Tollens reagent. Okay, all right. So you have to check on this. Okay, you can refer to lecture note in your lecture note between ketone, Fehling and Tollens reagent are the tests that we use to distinguish ketone and aldehyde. Okay, to distinguish aldehyde and ketone. So aldehyde will be the one that give positive result. I mean that give reactions to Tollens and also Fehling reagent, but not for ketone. Okay, so kena ni lah, kena refer. Cuba let's look at the slides. Okay. We have aldehyde ketone kan. So we have the chemical test for carbonyl compound. So we have tolerance reagent. So for tolerance reagent, it is also known as silver mirror test. Okay, so this one only aldehyde will give positive result for tolerance reagent with reaction with tolerance reagent. Okay, aldehyde will be oxidized, but not for ketone. Ketone give no reaction. Okay, same goes to Fehling. Fehling also give positive result. That means it changes the color for aldehyde. Okay, it changes the color. Initially, it is deep blue color of the Fehling reagent, and it's later turn to brick red deposit, brick red color lah solution. Okay, so this is only for aldehyde. Okay, this is applicable for aldehyde, but not for ketone. Okay, so the answer will be again all aldehyde. So all these four: pentanal, 3-methyl-butanal, 2,2-dimethyl-propanal, and 2-methyl-butanal. Okay, all right. Number three, we have three questions. The compound give yellow precipitate with iodine in alkaline solution or iodoform test. So when we have yellow precipitate, it represents the iodoform test. So the question, you have to choose the one that give positive results to iodoform test. Of all the compound that you have drawn here, okay, choose the one that give positive results to iodoform test. So iodoform test is quite specific. Okay, it is actually referring to methyl group. Okay, of course, methyl group. It is referring to methyl 1. Okay, and then the other one is, of course, the carbonyl, the carbonyl group. Okay, the carbonyl. So it's different compared to alcohol. Okay, for alcohol we have to have methyl, OH, and also hydrogen. But for carbonyl, we need to have methyl and also the carbonyl group. Okay, we don't have to have hydrogen for this one. Okay, so kita kena identify. We have to check each one of them. Okay, pentanal will not give positive results to iodoform. How about 3-methyl-butanal? Okay, we do have the double bond O, but we don't have, if we are focusing on this carbon, kan, kita focusing on this carbon. So this carbon is not attached to methyl group. So this is not methyl group. Okay, so 3-methyl-butanal will also give negative result to iodoform. How about 2-methyl-butanal? Okay, so this carbon is attached to double bond O, and this again is not methyl. Okay, how about 2-pentanone? Okay, 2-pentanone. So this carbon is attached to the carbonyl, and it is also attached to the methyl group. Okay, all right. So it obeys this. It satisfies the two rules. So this will give positive result to iodoform test. How about 3-pentanone? How about 2,2-dimethyl-propanal first? Okay, all right. So this carbon is not attached to methyl group. So this is not methyl group. Okay, so it is also will not give positive result to iodoform. How about 3-pentanone? So this carbon, okay, is attached to ethyl and another ethyl group, so it will not give positive result to iodoform. This one, 3-methyl-2-butanone, okay, it is attached to 1-methyl group and also the carbonyl group. Okay, attached to double bond O. So this also will give positive result to iodoform test. So we have two lah. Okay, we have two compound that give positive result to iodoform. So we have 2-pentanone and also 3-methyl-2-butanone. Okay, all right. So those are the two answers for question number 3. And then C. This is A. This is supposed to be B lah. Oh, kan? This is supposed to be B. Tak tahulah. Okay, ada rupanya. Okay. Bonded association. Okay, all right. So 2-pentanone and also 3-methyl-pentanone. So this one, it detects this. Okay, it detects this. Okay, that is for iodoform just now. All the aldehyde. Okay, only aldehyde and also yes, only aldehyde. Okay, so kita ada tambahan lah just now. Okay, very good. Tu dah minta propana. Ada rupanya kat bawah ni. Tapi dekat dalam saya punya answer scheme, it should be B, question B, not C. Okay, alright. Okay, number 29. Show schematically how you would carry out the following conversion. Okay, so this is the starting material, the starting compound, 2-bromopropane. We will want to convert this into propanone. So how would you carry out the reaction in order to convert the 2-bromopropanone propane, 2-bromopropane, which is the alkyl halide, to propanone. Okay, propanone is ketone. So from alkyl halide to ketone. So macam mana nak plan? Macam mana nak carry out this reaction? So you must know all the reaction involved basically for alkyl halide and also the carbonic compound. Then only you could combine the reaction in order to produce the final product. Okay, so alkyl halide. So this is 2-bromopropanone. Okay, so first, before it can be converted to propanone, it need to be converted into alcohol first. Okay, sebab daripada alkyl halide, in alkyl halide punya slide, we don't have a direct reaction of alkyl halide forming carbonic compound. We don't have that, kan? Betul, kita tak belajar yang tu, kan? Tapi we can go through steps. Okay, a few steps and finally produce the ketone. So apa cadangan conversion kita tu? Okay, so we're going to start with alkyl halide. The 2-bromopropane undergoes the nucleophilic substitution. Okay, so it will form the 2-propanol. So basically, we want to replace the Br with OH, and then this OH later can undergo this one. Okay, all right. This is okay. This is just to highlight the nucleophilic substitution lah, the type of reaction. Okay, this is the reagent used. Okay, all right. So Br react with sodium hydroxide in aqueous, also in reflux. Okay, so to convert ataupun to replace the Br with OH, and then this OH, this is alcohol, okay? It will undergo oxidation reaction and finally produce the 2-propanone. Okay, inilah kita punya planning kita lah. Okay, from alkyl halide, convert into alcohol first. Okay, and once they become alcohol, then only we can convert into carbonyl, which is in this case ketone. So ketone is actually produced from secondary alcohol. Okay, ketone datang daripada secondary alcohol. So this is correct. Ethanolic, alkyl halide. Ethanolic. Okay, let me just check alkyl halide. Kenapa dia pakai ethanol? Not in aqueous, dia in dehydrohalogenation. Answer scheme. So it should be in aqueous lah. Yep, this one. Okay, that's better. Okay, so this is correct. Flux. and then KMNO4 H plus and heated. Okay, right, hot. Betul. Okay, B, propanon to 2-methyl 2-butanol. Okay, all right. So from ketone, so this is ketone, nak convert into alcohol. Like I said just now, ketone can be produced from secondary alcohol. Okay, when you try to draw these 2-methyl 2-butanol, so how would it look like? 2-methyl 2-butanol. So you may need to draw for both compound, okay, the starting compound and also the product, so that you can get idea from it. So the type of reaction that the starting compound can undergoes in order to produce the final product. So this is propanon. 1, 2, 3. Propanon, so becoming 2-methyl 2-butanol, is it? Oh, ada pertambahan carbon obviously. So this one we have 3 carbon. So this one bila you draw, it produce 1, 2, 3, 4. So dia butanol kan. 1, 2, 3, 4. Then carbon number 2 we have OH and also methyl. Oh sorry. Okay, we have methyl group. So obviously daripada 3 carbon kepada 4 carbon ada pertambahan, there is an addition of carbon to propanol, because initially it was 3 carbon, now they become 4 carbon. Okay, so kalau nak tambah rantai carbon, dia kena one of the way is to use the Grignard reagent. Okay, the Grignard reagent. So remember when we use the Grignard reagent, it can produce the product can be the alcohol can be produced. Okay, let's look at the apa nama ni? The slides. Okay, so this one. See, so initially it depends on the Grignard reagent used, the alkyl group in Grignard reagent. Okay, so this is the carbonyl compound. So it has only 1 carbon. So when it reacts with the Grignard reagent, the alkyl Grignard reagent, as you can see, okay, there is an increase of carbon number. So initially dia 1, now dia jadi 3. Okay, so we could and initially it is a carbonyl compound. Now they become alcohol. Okay, so sama juga the rest of the example here. So dia daripada carbonyl dia become alcohol, and this alcohol is a tertiary alcohol, right? So dia adalah tertiary. This is tertiary alcohol. Okay. Alright, so kita boleh ketone daripada alcohol. So can either be Grignard or reduction depending on the degree of alcohol. Okay, so this, like I said just now, is a tertiary alcohol. So reaction with Grignard reagent. So we're going to start with 2 propanon, the starting compound, and then we react it with this one, CH3CH2. Okay, CH3CH2 MgBr. So this is the Grignard reagent. So this one dia akan jadi nucleophile because dia carbanion. This one plus kan, so it will attack the carbon that is directly attached to the oxygen. Okay, and then this later on, okay, will form O minus, and O minus will then attack the H3O plus. So you have to have the H3O plus lah here. You kena ada dry ether, and then you have to have H3O plus. This will be number 1, this will be number 2. Because this OH, this O later on will attack the hydrogen from H3O plus. Dia akan jadi OH. Okay, alright. So disambung je. Terus je you attachkan the CH2 ni dekat belakang ni. So CH2 So dia akan ada macam mana? This one. This is CH2 and this is CH3. Betul tak? Yang dia lekat kat belakang ni. So CH2, CH3. Kalau you nak exactly based on the two propanol in there just now, so you akan ada sini akan jadi OH. So you akan attach this CH3 and CH2. This is CH2 and this is CH3. Okay, it's the same thing. Ni sama ni. Sama. Cuma you rotate lah the structure. So you akan dapat this form. Okay, so you akan dapat, you just attach the alkyl group of the Grignard reagent, okay, to the electrophilic carbon yang attached to the oxygen. And then don't forget the oxygen should be attached to hydrogen. So dia jadi OH lah. Okay, so this is 1, 2, 3, 1, 2, 3. This is it? Oh no. 1, okay, 1, 2, 3, 4, okay. 1, 2, 3, 4. So it is butanol. Okay, carbon number 2, we have OH, right? So 2 butanol, and then we also have methyl group. So it is 2 methyl, 2 butanol. Okay, by using Grignard reagent. Okay, C. Butene to 2 butanol. Okay, in butene subtopic last time, we don't have a reaction to directly convert the alkene to carbonyl compound. Okay, we don't have that reaction. Tapi maksudnya if we don't have that reaction, that means we have to convert this butene into something else first, and then this intermediate product will be then converted into 2-butanol. Sebab kita tak belajar butene, alkene convert directly to form ketone. We don't have that. Okay, right. So alkene need to be converted into secondary alcohol. Okay, maksudnya kita kena masukkan, kita kena jadikan dia alkohol. Maksudnya we have to add OH into alkene, and that reaction is known as hydration. Okay, so remember the reagent used to perform this hydration reaction, and then from this secondary alcohol will undergo oxidation in order to form ketone. Okay, sebab the final product is butanol, so it is a ketone. Okay, right. So this is butene. This is butene. 1, 2, 3, 4. Okay, so the double bond is between carbon number 1 and number 2. So it will undergo hydration reaction. Okay, not sure, don't remember this one, but I remember for hydration you may use H3O+. Okay, so let's just check hydration for alkene, the reaction. Okay, alkenes. Hydration, yes. Okay, we do have H3PO4 and heat. Okay, or you can also use, you can just simply use H3O+ lah. Okay, you can just simply use H3O+. This one, sometimes we use this one H3O+ to represent the hydration reaction. So either one is also acceptable. Okay, all right. So this bond will be, this pi bond will be broken down. Okay, so OH will be placed at the secondary carbon, not at the primary carbon. So it will be placed here. So this is known as 2-butanol. And this later will undergo oxidation with potassium permanganate, or you can also use dichromate. Okay, and don't forget the H+. And finally oxidize. Okay, this secondary alcohol will undergo oxidation to form ketone. Okay, it will form ketone. So this is known as 2-butanol. Okay, all right. Right, then next, number 30. Both organic compound X and Y with straight chain molecular formula contains 6 carbon and 1 oxygen. But compound X, so both of them will have 6 carbon, okay, and then hydrogen. We don't know how many hydrogen there, but we okay. Let's just put this one X, and then oxygen, 1 oxygen. Okay, 1 oxygen. But compound X has more 2 hydrogen than compound Y. Okay, that means compound X has extra 2 hydrogen compared to compound Y. Okay, all right. So we have C6H6O. Okay, so Y has 2 hydrogen extra than X. Okay, let's replace with this one with Z lah. Okay, okay, so kat sini we have to predict lah. Okay, so a few experiments were set up to investigate the presence of functional group and the structure of both compound. The following tests and results are shown below. Okay, paling obvious adalah kita mesti nak teka dia sama ada satu aldehyde ataupun ketone. Kalau if these two are considered let's say these two are carbonyl compound, they both should have the same chemical formula. Betul tak? Cuma satu aldehyde, satu ketone. Dia patutnya mempunyai the same chemical formula. But these two are not having the same chemical formula sebab dia punya hydrogen dia berbeza. Okay, so kita boleh predict dah dekat situ. Satu tu mungkin, okay, Y tu, X, terbalik compound X has more 2 hydrogen than compound, bukan kat sini. This one has 2 hydrogen extra than Y. Okay, so kat sini kita boleh agak dah. Y is a carbonyl compound, whereas X is not carbonyl compound. Most likely it is an alcohol. Sebab dia ada satu O juga. Dia ada satu O. Maksudnya apa possible functional group that consists of 1 oxygen. Okay, so one of it will be alcohol ataupun having hydroxyl group. Okay, so that's the rough idea that we have lah. So it definitely not aldehyde and ketone. Dia mesti salah satu, dia satu tu is either aldehyde or ketone, the other one should be alcohol. Sebab if both of them are carbonyl compound, they both should have the same chemical formula. Okay, so that's the tips lah based on the information given in the question. Okay, so kita nak deduce atau kita nak predict the structure of X and Y. So given the tests conducted in order to identify the compound X and compound Y. Okay, if both compound are subjected to these 4 tests, okay, so these are the observation that we could obtain. Okay, so for iodoform test, it will give positive result to compound X, but not for compound Y. Okay, alright. So kat sini kita predict dah yang Y ni is either aldehyde and ketone, or it should be aldehyde or ketone. Okay, so this one kita kena identify either it is aldehyde or ketone. This one kita predict that it should be alcohol. It should be alcohol. Okay, X. Okay, so kalau compound X is alcohol, it gives positive result to iodoform test. That means it should consist of CH3 it should consist of hydrogen and also OH lah. Okay, ini tips yang kita boleh dapat from the iodoform test of compound X because it give positive result. But compound Y will not give positive result. Yelah. Okay, bukan yelah. I mean, like I say, iodoform test is very specific kan. So this is not that helpful in order to determine whether it is an aldehyde or ketone. But at least we know that the carbonyl compound does not consist the methyl group directly attached to the carbonyl group. Okay, that is directly attached to the carbonyl group. Okay, so kita tahu itu. And then Brady's reagent, okay, there will be no precipitate form for compound X. Okay, betul lah. Brady's reagent only give positive result to yellow-orange precipitate to carbonyl compound only. Okay, for both ketone and aldehyde. So dekat sini pun kita still tak tahu whether it is an aldehyde or ketone. Tapi kita tahu dia carbonyl compound. It's not carboxylic acid, it's not ester. Okay, it is carbonyl compound. And then dia tak consist of, dia ada carbonyl group, but it does not, the methyl group is, the methyl group is not directly attached to the carbonyl carbon. Okay, okay, now Lucas reagent. It gives cloudy solution in a few minutes. Okay, so this is alcohol will not give positive results to Brady's reagent. It gives a cloudy solution in a few minutes. Few minutes, that means it should be secondary alcohol because Lucas reagent promotes SN1 reaction, prefers tertiary kan. So now they give cloudy solution in a few minutes. So it is secondary alcohol. Okay, kita tahu dah that alcohol must be a secondary alcohol. But for compound Y, which kita predict whether sama ada di aldehyde or ketone, these two will not react with Lucas reagent. So there will be no cloudiness formed at all. Okay, so betul lah dia punya prediction, dia punya observation. And then when we react with hot CHM096, which is the oxidation reaction, the X compound will decolorize the purple solution. Okay, alright. Just now kita dah predict that dia adalah secondary alcohol, and then of course lah the secondary alcohol, okay, consists of one oxidizable hydrogen. Okay, so they consist of, katakanlah this is R, this is OH. This is R, and then we have one oxidizable hydrogen. So this carbon is secondary alcohol kan? So R need to be determined lah. Okay, so it consists of oxidizable hydrogen, therefore it can be oxidized and it decolorizes the purple color solution of CHM096. Whereas, this is very important, okay? But for compound Y, it also decolorizes the purple color solution. Okay, it also decolorizes the purple color solution. So we can differentiate whether we can identify whether it is an aldehyde or a ketone. Okay, since it can decolorize the purple color solution of CHM096, therefore it should not be ketone. Okay, it should be aldehyde. It should be an aldehyde. So that's the idea of it. Kita dah tahu dia aldehyde, dia tak consist of methyl group, and then dia ada 6 carbon, dia kurang 2 hydrogen of course, and then dia ada 1 oxygen. So based on that information, how can we draw? Okay, so we should be able to draw the structure of the structure of X and also Y. So following question will be deduce the structure of compound X and Y. So you kena predict lah. Okay, based on the information given, you predict the structure of X and Y. Syarat dia kena ada C kena 6, H, and then we ada O. Okay, ini kita nak kena determine lah. Bukan ni Z. Okay, right, and then dia secondary alcohol. And what else? Secondary alcohol. Oh, it give positive result to iodoform test, right? That means it consists of carbon yang attached to OH, also attached to CH3 and also attached to hydrogen. So dia mesti macam ni. Okay, because this part right here give positive results to alcohol, to iodoform test. Okay, so like what Christina did, so this part yang bagi positive result to iodoform test, and then this carbon is secondary sebab tadi dah predict kan, this secondary give cloudy solution in few minutes, and then purple solution decolorized because of the presence of this hydrogen. Okay, the rest tu kita follow through lah, maksudnya dia kena ada 6 carbon, 1, 2, 3, 4, 5, 6 carbon. Okay, so it is 2-hexanol. Okay, how about Y, guys? How about Y? Okay, so kita kena check balik. Okay, so kita tahu dia adalah aldehyde. Okay, so this is aldehyde. And then aldehyde will be oxidized. Okay, it decolorize the purple color of CHM096. Betul. Then what else? It also react with Brady's reagent. Betul. And it does not give positive results to iodoform test. Maksudnya dia tak consist of this carbon, does not attach to methyl group. So this is not methyl group. This is 1, 2, 3, 4, 5. This is pentyl group. Okay, no wonder lah dia tak bagi positive result for iodoform test just now. And dia ada 6 carbon, hydrogen dia less 2 hydrogen than 2-hexanol just now. Okay, it has less 2 hydrogen compared to alcohol just now. So it has 1 oxygen. Okay, all right. So yeah, so that is for Y. Okay, it is hexanal. The compound Y is hexanal. Okay, all right. So that is all for aldehyde and ketone. Okay, thank you, everyone.